Here it is. People enter a line for an escalator at a rate given by this function. So what you're noticing is in the first 300 seconds, it has a rate, and then all of a sudden, after 300 seconds, people are no longer entering the line. Okay? So that's the rate. A. I'm going to use my pointer. And I guess I should read this part too. Where RT is measured in people per second. So this is a rate. As people get on the escalator, they exit the line. So they're exiting at a rate of 0.7 people per second. There are 20 people in line at time equals 0. So initially 20 plus. Think that. All right, A. How many people enter the line for the escalator during the time interval 0 to 300? Okay, I didn't ask how many total people have gone through the line. How many people enter the line? So we don't care about that 20 at the beginning. All I want for A is simply going to be the integral from 0 to 300 R of t d of t. And I'm hitting pause on my calculator or my record. Okay, I'm recording. Anybody who feels super good about it? Corey?
Yeah, 270.
Right on the money. What does that mean? Over those 300 seconds, 270 people entered the escalator. Okay. Yeah, well, I think that's fair. 300 seconds, 270 people get on an escalator.
That's
300 seconds.
That's 5 minutes.
It's 5 minutes, guys.
almost
Now it doesn't seem like much. Okay? All right. So we have that. B. Let's read B. I think I can make this fit. All right, let's read B. During the time interval from 0 to 300, there are always people in line for the escalator. How many people are in line at time 300? Okay? How many are at time 0? Plus, we just found how many got in line over those 300 seconds, which is what? 270. And people are exiting also, aren't there? Minus, what's the rate we're exiting? 0.7 people per second. So minus 0.7 times 300. I'm going to hit pause. Recording. What did we end up getting? 80. Okay. Feel good about those two parts?
No.
Well, I'm trying to expose you to more, so we'll go from there. I'm going to erase.
Try one with my chocolate. Like, I don't know how to plug it in like that.
Well, I can help you with that. Okay? Maybe not right this moment, but I can help you. All right, so I'm going to erase this so I have room to write my rest. I'm sure there's a way to erase it and make it easier. Yeah, I'm sure there is. I'm committed now. And I'm even recording me erasing it. It's even better. All right, C. When time becomes greater than 300, what is the first time t that there are no people in line for the escalator? So see how we immediately become nothing's entering once we hit 300, right? Now what did we just say? How many people total? What did we just get for answer B? 80. So I have 80 people. And I'm going to flatline at some point. But I'm minusing, I'm still exiting at what rate? 0.7
They worded the question terribly.
t. I want to know when that equals 0.
Isn't it like
So let's find that t value.
at time 300 there are no more people in line for the escalator, there's still people on the escalator.
And you get 114. Is that correct? Hold on, that's not the answer though. All right. That's occurring. That's how many seconds after how many seconds? After the first 300 seconds, this is occurring. This 80 came from the first 300 minus this to get there. So our total is at 300 seconds plus that. So the answer is 414.286 seconds. D. From 0 to 300, at what time t is the number of people in line a minimum? You should right now know derivative. You should think in derivative. To the nearest whole number, find the number of people in line at this time, justify your answer. Okay. How many people started?
20.
Plus, from 0 to what time? I'm asking for what time is my rate entering r of x d of x minus the 0.7 t. Let's talk about this again. Let's see what this is. See if you can follow me. We had 20. We're entering at some rate. Yes. Exiting at this rate. Agree? So this is the function. But I asked for, well, how do we find the minimum? So if this is my function, take the what of this function? Take the derivative. Don't we define absolute max and mins? Find critical numbers is when the derivative is equal to 0. Or define. You guys did this already in part B, didn't you? Isn't this your part B? Except you had from 300, right? I don't know it's 300, so I had to do this. Now think about it. What's the derivative of 20? Gone. Okay, what's the derivative of the antiderivative of a function? Remember what you would do? To take the derivative, you plug in t. And what's the derivative of t? 1. So it just becomes the function r of t minus, again, I did the second fundamental theorem of calculus again. The derivative of the antiderivative becomes plug in t, the derivative of t is 1. Minus, what's the derivative of 0.7t? Just 0.7. And critical number is we set the derivative equal to 0. Agree? Okay. So, now you're going to have to do some work. You already have this graph in your calculators, yes? I would want to know, when does r of t equal 0.7? Here's my suggestion to do this one. You're in your calculators. Guys, don't change this function. How can I find where the function you already have in your calculator is equal to 0.7? My suggestion would be go in and make a second equation of y equals 0.7. So graph this and find the points of intersection. You're going to have to change your window. You know your window's somewhere between your x values between 0 and 300. You following me? And you're going to have to find those t values. So I'm going to hit pause. And continue to resume recording here. And again, so I would do the x range from 0 to 300, and I'm having students tell me to go from the y range from 0 to 5. And one of your t values, Eli, what do you think it is?
166.57.
Yep, 166.5. I'm going to write it out. 57472. Anybody else getting that? And your other t value, somebody else. It's the smaller one. Somebody else find the other one?
33.0.
Got it. 33.013298. Why am I not rounding? Because that isn't the question. Okay, it's part of the question. At what time t is the number of people in the line a minimum? Why, that isn't the answer yet. To the nearest whole number, find those number of people. So from here, and I'm going to have to write on the screen all over the place. From here, I would say, okay, I now need to find it at 0 and 300, I already have those values. At time 0, we already said there was 20 people. At time 300, we found that in part B, it was 80. We need to find time 33 point whatever and 166 point whatever, and you're going to find that by going back into the equation of 20 plus 0 to whatever your time is, r of x, d of x, minus the 0.7t. So it's going to take you a moment. It's like part B where you're going to go back and plug in those values. Okay? When you plug in the 33 seconds, you're going to end up with 3.803 people. I know around the nearest whole number. And when you plug in that 166, you're going to get 158.070. So I'm ready to answer my question. At what time t is the number of people in line a minimum? At that 33.013298 seconds. And it says to the nearest whole number, find the number of people in line at that time. I would say 4 people. My justification was from showing that I set the derivative equal to the 0, and then I set the derivative equal to 0.7, and then showing the endpoint outputs and the critical number outputs. And then I'm going ahead and go and hit stop.